2, 1, start. Good morning, students of grade 8. Welcome to grade 8. First of all, you have completed your grade 7, and today in grade 8 we are first of all going to study about our lesson number 1, measurement. And measurement is the first lesson from physics, and physics is the study of natural things. Yes, now come to measurement. As you have studied in grade 7, let's revise something from your grade 7. You know what is measurement? Measurement is better you also start to write. Measurement is the process of comparing unknown quantities with known quantities which are considered as the standard or a reference. Okay, measurement is the process of comparing unknown quantities with known quantities which are considered as the standard or a reference. Let us suppose that you can see this rod. Yes, I do not know the length of this rod. I want to know the length of this rod, whereas I am taking this as a standard. Okay, this is just an example. I suppose this as a standard, and I consider it to be 1 unit. I consider it to be 1 unit. Now, considering this as 1 unit, this becomes a reference or a standard. I took this as a reference or standard, and this is considered 1 unit long or 1 unit length. Now let's compare this unknown quantity, this rod, with our standard quantity. Starting from here, you can see up to here it becomes 1. Yes, and then from here let's continue 2, 3, okay, 4, 5, 6. Okay, approximately 6. So this rod compared to this standard, we know that this rod is equivalent to 6 times the standard unit. If I consider this as unit, then length of this rod would be 6 unit. If you consider this as 1 unit, then length of this rod would be 6 unit. Now what did we do? We did not know the measurement of this rod, but taking this as a standard, we took measurement of this rod in reference to this standard. So if I consider this as 1 unit, then it is 6 unit. If I say this is 1 meter, then it would be 6 meter. If I say this is just say 1 cap length, then this rod would be 6 cap length. Similarly, in ancient time also, our ancestors, they used several common objects as standard. For example, hand. Okay, you might have heard about it. Ek hat, dui hat, teen hat. People used to measure things like that. When the length approximate to our hand or our palm is or the length approximate to your tip of finger to elbow, okay, or the length approximate to your feet, all of them can be considered as standard quantities or reference quantities. Okay, now let's go to next. Now that you know that measurement means the process of comparing unknown quantity with known quantity which are considered as the standard or reference. Now come to next topic. Here you can see quantity. What do you mean by quantities? Quantities is any physical entity. Okay, any physical entity or phenomenon, okay, that may or may not be measured, that may or may not be measured. And another feature of quantity is you can compare them. You can compare them to the relative term. Okay, such as more versus less, strong versus weak, okay, long versus short, fat versus thin, etc. So whatever physical entities that can be compared in relative terms, or that may or may not be measured, they are called quantities. Okay, whatever physical entity that may or may not be measured and can be compared to the relative term are called quantities. Now you see that some quantities can be measured and some quantities cannot be measured. So based on that, there are two broad categories of quantities. Those quantities that can be measured are called physical quantities. Okay, those quantities that can be measured, that can be measured are called physical quantities, and those quantities that cannot be measured are called non-physical quantities. Now non-physical quantities means that can not be measured. Some examples of physical quantities are length, okay, height, weight, time, etc. And some example of non-physical quantities, happiness. You know that when person are happy, you can say he is more happier than she, or he is less happier than she, or you can compare them, but you cannot actually measure happiness, sadness, grief, etc. Now see, non-physical quantities are actually those quantities to measure which we do not have any technology yet. Okay, जुन टेक्नोलोजी जुन फिजिकल जुन क्वान्टिटिजहरूलाई मेजर गर्ने कुनै टेक्नोलोजी बनिसकेको छैन, they are non-physical quantities. Now suppose that in future some scientists discover a technology to measure happiness of a person, then we will categorize happiness as physical quantities. But as of now, there is no technology to measure happiness of a person or sadness of a person. That's why these are still non-physical quantities. That means non-measurable quantities. Now let's revise it once again. Measurement is the process of comparing unknown quantities with known quantities, which are considered as the standard or a reference. Okay, and how do you define quantities? Quantities means those physical entity that may or may not be measured and can be and we can compare them to the relative term. Okay, quantities are those physical entity that may or may not be measured and we can compare them to the relative term. Okay, and such for some examples of relative term are more versus less. By comparing, you can say it is more, it is less, or strong versus weak, long versus short, fat versus thin, etc. You can give other relative terms as well, like bright versus dark, good versus bad. Okay, so now from this definition, you know that there are two broad categories of quantities. Some quantities can be measured, they are called physical quantities, and some quantities cannot be measured, they are called non-physical quantities. Okay, some examples of physical quantities are length, height, weight, time, etc. And examples of non-physical quantities are happiness, sadness, grief, etc. And know this is just technical term. That means if we have technology to measure some quantities, then that becomes physical quantity, we can measure it. But if we do not have technology to measure some quantity, then that quantity becomes non-physical quantity. In future, if some technology has been invented to measure such quantities, then they will be categorized as physical quantities. Okay, next title, we have types of physical quantity. Types of physical quantity. Now, some of the physical quantity we can measure directly, whereas some physical quantities cannot be measured directly. We need to rely on other physical quantities to measure such quantities. Okay. For example, if we need to measure how long is this pen, then you can directly use a scale and measure it, just as I've shown you an example earlier. Yes, you can directly measure this pen. But if you have to measure how fast a vehicle, a car is moving, suppose this car is moving, yes, how fast this car is moving, you need to measure its speed. Can you do that in one step? No, you cannot do that in one step. To measure speed of this car, what you need to do, first you need to measure the distance covered by the car. Okay, you need to measure distance, what distance is covered by the car. Okay, and after that you need to measure time taken by car to cover that much distance. Measure time taken by the car. Okay, first measure what distance is covered by car, then measure time taken by the car, and then after you divide distance by time and you get speed of the car. See, so measurement of speed is two-step process. This measure distance, then measure time, then divide distance by time. Okay, sorry, three-step process. So speed actually depends on distance and time. So we can safely say that speed cannot be measured directly. Although technical inventions, new technical inventions combine these two measurement, okay, these two technology to measure these two entities, and then they give us that they directly give us the value of speed of moving car. We also call that speedometer. Okay. So what I was saying, that some physical quantities like distance, they do not depend on other physical quantities, and time also do not depend on other quantities. However, some physical quantities, they depend on other physical quantities. So in that regard, we can categorize physical quantities into two types. They are fundamental quantities. You are familiar with this, fundamental quantities, and derived quantities. Now, if I ask you what is fundamental quantity, you probably already know this. Those physical quantities that do not depend on other quantities are called fundamental quantities. You also start writing in your copy. Okay, those physical quantities that do not depend on other quantities are called fundamental quantities. And derived quantity, those physical quantities that, see here, fundamental quantities do not depend, but derived quantities that depend. This is the only difference. On two or more other quantities are called derived quantities. And you see, physical quantity, you already know, those quantities that can be measured are called physical quantities. And there are two types of physical quantities, and they are fundamental quantities and derived quantities. Those physical quantities that do not depend on other quantities are called fundamental quantities, and those physical quantities that depend on two or more other quantities are called derived quantities. Now, some examples of fundamental quantities. Actually, there are only 7 fundamental quantities in physics. There are only 7 fundamental quantities, whereas there are many derived quantities, uncountable derived quantities in physics. Okay, now among these 7 you can say length, you already know this, yes, and then after mass, time, current, temperature, luminous intensity. Luminous intensity means how bright is an object. This is used in light chapter. This is related to light. And amount of substance. Amount of substance actually refers to number of molecules or atoms present in a matter. Again, I can see there are 7 fundamental quantities: length, mass, time, current, temperature, luminous intensity, and amount of substance. See, 1, 2, 3, 4, 5, 6, 7. These 7 are fundamental quantities involved in physics. Now, derived quantity, you can easily give many examples like speed slash velocity, density, acceleration, work slash energy, power, etc. You can give many examples of derived quantities. Now let's discuss about units. Okay, whenever we express a physical quantity, we say that like a mass of an object is 7 kg. We say something like this, yes? We do not just say 7, we say 7 kg. Similarly, weight of a man is say 450 Newton. Once again, see, we do not just say 450, but we say 450 Newton. Let's take another example. If you go to a shop and ask to buy sugar, okay, what would you say to the shopkeeper? Would you just say, please give me 2 sugar? Do you say like that? No. What you say? Please give me 2 kg sugar. You say something like that, yes? Or please give me 1 kg sugar. You say something like that. Or sometimes if you need to buy less, you can say, please give me half kg of sugar. Or I want 200 gram of sugar. Okay, you say like that. Or take another example. If I ask, what is your height? Your height. You might say that my height is 5 feet. Or some say that my height is 5 feet and 2 inches. Or some say that my height is 1.7 meter. Or if I ask you height of a building, you might say that height of building, you might say that this house is around 12 meter high. You say something like that, yes? But would you say that height of a building, this house is 12 high? No, you do not say something like that, yes? So while physical quantities are expressed, it always contains 2 parts. One is numerical part and another is reference. This is numerical value and this is reference. Okay. Now this numerical value, you already know, this is actually the quantity, yes? Now the reference, this reference is known as unit. This reference is known as unit. And this is known as quantity. So expression of any physical quantity involves 2 parts. They are quantity and unit. So here, if I say 5 feet, then you know that this is quantity. Okay, this is quantity. 5 is quantity and feet is unit. It means that feet is a standard object, standard length. Okay, feet is a standard length and 5 feet means that object is 5 times as long as that standard length. Suppose that I consider this dot pen, length of this pen as 1 feet. Suppose, just suppose, it's not true, but if I suppose that length of this pen is 1 feet, then you can say that that object which have 5 feet length is 5 times as long as this pen. Understood? Okay, so you can define unit as, okay, now copy this. Unit is defined as the standard or reference quantity. Unit is defined as the standard or reference quantity which can be used to measure unknown quantities of the same kind. Unit is defined as standard or reference quantity which can be used to measure unknown quantities of the same kind. Okay, for example, a scale can be used to measure length. Okay, you cannot use a scale to measure mass of an object. Or can you say that weight, what is your weight? If I ask you what is your weight, or can you say my weight is 5 meter? No, nothing like that. Yes. Okay, for example, some examples of unit is meter, centimeter, millimeter. Similarly, some units used to measure mass. They are kilogram, gram, milligram, ton, or quintal, etc. If we need to measure time, units used in measuring time are second, minute, hour, day, week, month, year. These are all the units which are used to measure time. Similarly, other units, let's say a unit of work, joule, a unit of force, Newton, unit of power, Pascal, unit of pressure, Pascal, unit of power, watt, unit of density, kg/meter cube, etc. Okay, these are some units which are frequently used in physics. Now, you know that there are two different categories of units. Okay, two different categories or types of unit. These are fundamental unit, and derived unit. Fundamental unit and derived unit. Now, those fundamental units means those units which are used to express fundamental quantities. If the units are used to express fundamental quantities, then they are called fundamental units. And if the units are used, okay, those units which are used to express derived quantities, then they are called derived unit. Or basically you can say those units do not depend on other units. Okay, those units that do not depend on other units, they are fundamental units. Whereas derived units, those units, they actually depend on two or more other units. They are called derived units. Now, in physics, I already told you there are 7 fundamental quantities. Yes? Okay, there are 7 fundamental quantities. Means how many fundamental units there should be? Okay, if there are 7 fundamental quantities, then there should be 7 fundamental units. Okay, for example, let's say length. To measure length, length is fundamental quantity. To measure length, we use meter, centimeter, millimeter, inch, feet, etc. Okay. Similarly, to measure mass, we generally use, in SI system we use kilogram. Smaller units of kilogram is gram, milligram, and larger units of kilogram is ton. 1000 kg is equals to 1 ton. Quintal, 100 kg is equals to 1 quintal. Similarly, in our local concept we use tarni. You know tarni? Tarni, pau, chatak, etc. These are all the units, fundamental units which are used to express mass. Similarly, time. What units do we use to measure time? In SI system we use second. Smaller units, larger unit of second is minute. Then hour. 24 hours, okay, 60 second equals to 1 minute, 60 minute equals to 1 hour, 24 hour equals to 1 day, and 7 days is equals to week, and then comes month, okay, and then 365 days is equals to year, okay. In our ancient system we use other units such as kadi, pala, prahar, etc. Okay. Similarly, let's go to another fundamental quantity, that is current. To measure what amount of current is flowing through a circuit, we use ampere. Okay, and another one is temperature. To measure temperature, we use, in SI system, Kelvin, and there are other systems in which temperature is measured in degree Celsius, degree Fahrenheit, etc. And then luminous intensity. Luminous intensity, it measures, I already told you, brightness of source of light, and its unit is candela, or CD. And this is quite easy to remember because this word sounds like a candle, and candle gives us light. Yes. Next one is amount of substance. Then it depends on number of molecules present in matter, okay, and its SI unit is mole. You will study about mole in higher classes, say in grade 11. For now, you just need to memorize the terms. Okay, now let's revise. Types of unit. There are two categories of unit. There are fundamental unit and derived unit. Fundamental unit means those units which are used to express fundamental quantities, and those units do not depend on other units. And since there are 7 fundamental quantities, and each of them have several sets of fundamental units. Length is measured. Some units used to measure length are meter, centimeter, millimeter, inch, foot, etc. And mass, some units used to measure mass are kilogram, gram, milligram, ton, quintal. In local system, tarni, pau, chatak, etc. To measure time, second, minute, hour, day, week, month, year, kadi, pala, prahar, etc. And to measure current, ampere. To measure temperature, Kelvin, degree Celsius, degree Fahrenheit, etc. To measure luminous intensity, candela. To measure amount of substance, mole. Okay, now next topic, last topic for today, we are going to discuss in short about derived units. You know that derived units are those units that are used to express derived quantities, and they depend on 2 or more other fundamental units. We'll take some example of derived units. For example, force. You know force? Force means an external agent that changes or tends to change state of an object from rest to motion or motion to rest. And it is also measured mathematically by using a formula, mass into acceleration. Force is measured by using the formula mass into acceleration. Now here you can see mass is already a fundamental quantity, whereas acceleration means change in velocity. You all know this. Acceleration is change in velocity by time. Once again, time is fundamental quantity, but velocity is not a fundamental quantity. So let me write it like this: mass into 1 by time into velocity. Okay, I separated change in velocity by time as velocity into 1 by time. We can do that. Yes. Now mass into 1 by time into velocity means distance or displacement divided by time. Displacement made per unit second is called velocity. Now you can see all of those terms are now fundamental quantity. Okay, and you can see that force actually depends on four other fundamental quantities. Force is a derived quantity. Now let's say a unit of force is Newton. Yes, and unit of mass is kilogram. Unit of time is second. Unit of displacement is meter, and once again unit of time is second. So Newton actually consists of kg meter slash second square. You might be asked in exam, what are the constituent of Newton? Then your answer should be Newton consists of kilogram meter per second square. And it shows that Newton actually depends on four other fundamental units: kg, meter, second and second. Since Newton depends upon four other fundamental units, Newton is a derived unit. Now give conclusion. Since Newton depends on four other fundamental units, and they are kg, meter, second and second, it is derived unit. Okay, now similarly, let's take another example of velocity. Velocity is defined as total displacement made by a moving object per unit time. Total displacement made by an object per unit time. That means mathematically we can calculate velocity by using the formula displacement by time. Now both of them, displacement and time, both of them are fundamental quantities. So you can take unit of these terms. Unit of displacement is meter. It is same as length. Okay, and unit of time is second. So you can see unit of velocity is meter per second or meter slash second. Here unit of velocity actually depends on two other fundamental units, that is meter and second. It is also derived unit. Give conclusion. Since unit of velocity depends on two other fundamental units, that means meter and second, it is derived unit. Okay, similarly now you can try others. Try to prove that unit of power is derived unit. Okay, similarly unit of density is derived unit, and unit of work is derived unit. Now these three are your homework. Try to prove that unit of power, density and work are derived units in the same manner as we have done just now. Once again, you can take screenshot of this process. This is for force, mass into acceleration, equals to mass into change in velocity by time, equals mass into 1 by time into velocity, is mass into 1 by time into displacement by time, and Newton equals to, that's why unit of mass is kg, unit of time is second, displacement is meter and time is second, and then give conclusion. Similarly, this is the procedure for velocity. Velocity equals to displacement by time. Displacement is actually same as length. Unit of displacement is meter, unit of time is second, so it gives you meter per second. Okay, now by using similar process, try to prove these three: power, density and work as derived units. Okay, send me your work in through messenger as a personal message to me. Okay, tomorrow if you have difficulty solving this, then we will again do it tomorrow. That's much for today. Thank you, class.